Let me welcome you for this session, which is very special. We are trying to give you a service at the occasion of this event, which is mainly your work, but we would also like to offer you something, and what we offer you is current, up-to-date, first-hand information on things that happened in space very recently. You notice that the International Space Station has recently turned from a construction site into a science station. Particularly, international contributions have been very active. We'll report on that. The moon also received increased attention, and it's particularly the two countries, India and China, who have pioneered this work. And this is what we will present you today. We have three extraordinary speakers tonight. There's, I'd like to introduce to you Bernardo Patti from ESA. There is Professor Susumu Sasaki from Japan, and there's Dr. Shifan Hao from China. And they will give you short presentations. Let me first introduce our first speaker, Bernardo Patti. He is the infrastructure manager of ESA. He's located in Estek in Noordwijk, and after having worked for a very exciting ESA project, Cassini-Huygens, he joined the space station team about 10 years ago. He worked on Columbus, the nodes, the ERA, the cupola, and other infrastructure elements. He must have experienced a dramatic change to his lifestyle very recently, when most of these elements went up, and they're actually up there now and working. And he will give us a report on what happened and what his babies are doing in space. Please, Bernardo. Thank you very much. While we're waiting for the presentation, I'd like to remind you of a point that has just been mentioned by Marcio. On the 9th and 10th of July, IAF will organize a meeting here in UNESCO on the 10 years celebration of ISS. And it will be organized by experts which are here in the audience now. Everybody who's interested can participate in this. Please note down 9th and 10th of July here in Paris. Okay.
Good afternoon. It's a great opportunity for my organization to be able to report on the last result of the ISS program, and it's a great honor for me to be able to represent my organization and to deliver this report. Few words about dramatic change of my life that you mentioned before. Like all the project managers that are launching something, I was extremely worried of the post-launch depression, because you know the baby is gone and you don't know what to do. But obviously this didn't happen, because we're ever so busy operating the station that I didn't have the time to get depressed. So I would like to tell you that everything works properly, and there is not a dramatic change in my life. Few words about the structure of my presentation. I am going to spend few minutes on giving you a big picture type of introduction of what the program looks like, where it is. Then I'm going to dwell on the three recent launches, the Node, Columbus, and ATV. I am going to spend a bit more time on the Node, on Columbus actually, and the fact that I am the Columbus project manager is just a pure coincidence. And then I am going to offer a few conclusions and a way forward for our program. So we had basically on the 23rd of October 2007, on the 7th of February 2008, and on the 9th of March 2008, respectively, the launch of the Node 2, the Columbus module, and the ATV Jules Verne. This is represent something like 50 tons of hardware put on orbit. So this is really serious business, especially if you know that the cost of a program can be very much equated to the cost per kilo. We had, in the same time of launching our element, we had the opportunity to have three European astronauts flying to the ISS, namely Mr. Paolo Nespoli, flying on the Node 2 assembly flight, and Hans Schlegel and Leopold Ehlert flying on Flight 1E on the Columbus assembly flight. This is a view graph that in our directorate we are very proud of, because this represents all what we have done together with our industry since something like 15 years. This view graph needs to be read clockwise, and it represents all the contribution of ESA to the space station. So we start with the data management, the computer of the Zvezda module, the service module, the Russian service module. Then we have the microgravity glove box being launched also in the year 2000, in 2002 actually. Then the EMCS, which is a payload, a scientific facility. Then the minus 80 degree freezer, which was launched in the year 2006. And more recently, as you can see, the Node 2, as I have mentioned, the Columbus module with all its payload facilities, then ATV. Now what remains to be launched is the ERA, which has a launch under review, the Cupola, and the Node, which will be launched in October 2009. So you can see that the circle is really closing. Few words now about the various recent launches that did occur. The first one is the Node 2. The Node 2 is an ESA build element built by Thales Alenia Space in Turin. It's not an ESA-owned element. It's ESA that has built this element to compensate NASA for the expenses they had to launch the Columbus flight, so the Columbus module. So instead of paying NASA in dollars, we have established this barter arrangement, which is widely used throughout the partner of the ISS, in order to compensate the effort that the other partner has done to put us on orbit. What is the function of the Node is, as you can see on that picture, is an interconnecting element that allows to link the US lab to the Columbus module, the Kibo module, and also to the HTV and to the Japanese logistic module. Few words about the development history. I have already mentioned that the prime contractor of the Node was Thales Alenia Space, and they have developed the Node 2 under the leadership of the Italian Space Agency that had the delegated responsibility to manage that given program. Few words about the 10A assembly flight, which is the launch of the node. So it was launched on the 23rd of October. After a flawless launch, the node was positioned on this intermediate position that I'm going to show here. Because the shuttle was here. Then, when the shuttle left the station, the node was repositioned in the front of the station where it is now. And since then the node is working flawlessly, delivering all the resources the other element attached to it requires. Now we get to the plat de résistance, which is our Columbus assembly flight. This was the 7th of February. For many of us it meant a lot. The Columbus development has been a bumpy road in terms of programmatic difficulties. We had suffered a number of slowing down in the program due to reasons that were not generated by the program itself. The shuttle accident is one of them. And it has been extremely challenging for us to keep the motivation of all the teams working on this program and to keep also the cost within the envelope we were assigned to keep. Few words about the Columbus performance. It's a 12-ton vehicle. It has about 13 kilowatts to the payload. It has 120 volt power. Also, it has communication capability up to 32 megabit per second. It provides active thermal control to its payload and to the subsystem, and it provides support for 3 crew members, and it has a design life of 15 years. What are its features as opposed to its performance? Columbus provides a short-sleeve environment for up to 3 crew members. Actually, this is not true, because during the Flight 1 mission there were up to 10 there, and apparently they did survive. Nevertheless, we did size it for 3. It can accommodate up to 10 payload scientific facilities and 4 external payload facilities on its external platform. It can operate 10 years on orbit. It has the capability to be repaired while working. Usually when you have a ship and the ship is to be repaired, you put it in a hangar or a plane and you repair it. This is a machine that still can deliver its normal services and being repaired. And this is introducing few little design complications that we have enjoyed. This is an intelligent system that can make his own health check and decide if he's healthy or not and reconfigure itself. Usually a satellite sends you some telemetry, and you see telemetry healthy or not healthy, and then you send a command from ground to reconfigure it. This is a system that is able to reconfigure itself. So he is able to detect his health and to cure himself, which is also a high degree of sophistication. And by its design, we have been able to maintain, we have generated, let's say, a very compact design that was able to remain within the 12-ton allocation, and therefore we had in one single launch all our infrastructure on orbit on the first go. Few words about the Columbus outfitting, which is actually the most sophisticated part of the Columbus program. Engineers like to see the Columbus like a big bus, and internally all the payload are like the expensive furnitures. We can see the 5 payload facilities and the 2 pressurized facility and the 2 external payload facility namely the European Transport Carrier, Biolab, the Fluid Science Lab, the European Physiology module, and the European Drawer Rack. Those are the internal payload facilities, and the external payload, SOLAR and UTEF. Those facilities have been developed under the leadership of my colleague and friend, Mr. Rebaldi, which is with us today. This is the Columbus module, just before hatch closeout, before we put it on the shuttle. This is the Columbus module being dragged to the airlock of the SSPF facility. You can see the gem waiting for his turn. His turn is going to come very soon, and we are extremely happy of that. And this is the SS-122 crew that did a so magnificent job in our mission. Now, get the opportunity to show you a little movie that will make, hopefully, the presentation more interesting. Am I doing well in the schedule? Thank you. Halfway through? Okay. Okay, good. So, first, let's have an overview of what is on the shuttle cargo bay. So you see, that's the docking system of the shuttle. That's where it docks to the station. Now you can see the remote manipulator arm of the shuttle on one side. On the other side, you see the OBSS, the Orbiter Boom Sensor System, that is developed to make the inspection of the shuttle tiles. This is required after the Columbia accident. This is the external payload facilities, and this is our Columbus module. A snapshot on the Columbus module. There's a major failure on the module? That's okay. A snapshot on the Columbus module. You can see its MDPS panel. You can see here the common berthing mechanism that attaches to the Node 2, and the external platform where the external payload are being attached. Now, how the module has been attached to the station, it is thanks to our Canadian friend, because you see the Canadian arm grabbing Columbus outside of the cargo bay and moving and attaching to the Node 2. This is it looks extremely easy and extremely fast, but it took 4 hours to do it. But that's what software can offer you.
Set sail on a voyage of science to the space station.
Those
Columbus weighs anchor.
Film speaks by itself.
In Florida.
This is already the cargo bay being open. This is the shuttle arm starting to be deployed in order to make the tile inspection. This is Anschlegel on the other side of the station, of the shuttle. This is the shuttle doing his looping maneuver to give the opportunity to the astronaut which are on the station to take picture and to see the health state of the tiles. This is the shuttle docking to the station. You can see, this is the Note 2, and this is the shuttle commander, Steve Frick, shaking hand after successful docking. This is the crew of the station encountering the crew of the shuttle. Hans Schlegel is our astronaut. And now you are going to see the assembly of Columbus. What you saw in the animation, now you are going to see in the real movie. You see the Canadian arm now going to grab Columbus on the cargo bay. Those are the astronauts doing some EV activities, and that's the Columbus slowly moving outside the cargo bay. It's a bit slower than with the software before. And that's the docking.
That's affirmative, Houston. Columbus is touching the station for the first time.
That was a very emotional moment for some of us.
European Columbus laboratory module is now part of the ISS.
It's been a historic day in human spaceflight.
It gives us the chance to learn how different people work, how different cultures work together, and how we can cooperate and produce something as magnificent as the ISS.
This is our control center. Two of our colleagues, my boss, yet again my boss. This is the astronaut doing the EVA to change the nitrogen tank assembly, which is an element of the truss. And you see the astronaut being dragged by the arm, carrying the tank. Quite impressive. And now he's finished his job, he's extremely happy. And this was the end result. No, they are not. 5 minutes? 10 minutes? Oh, fantastic. So, I'll show you the crew. This is the Columbus on the cargo bay, like you have been able to see before on the animation and on the movie. This is a beautiful picture of Columbus being extracted from the cargo bay by the Canadian SSRMS. And this is the end result, mission accomplished. The Columbus is part of the space station together with its payload facilities and ready to be operated and to deliver the science to the community that is waiting for it. We had also another major important event on the 9th of March, which was the launch of the ATV. So a brief snapshot of what is the ATV mission. ATV is being launched. It is getting to the station, doing automatic rendezvous, bringing the necessary cargo to the station, staying there for a boost maneuver for a period about 6 months, and then detaching from the station and performing a safe re-entry on the South Pacific. Few words about the ATV, and just to give the audience an impression of what class of vehicle we are talking about, and the figure is an honest figure, therefore the scale is being kept the same for all the elements, and you can see it is on the same order of Apollo, and significantly larger than the current Progress that is supplying the logistic to the station as of today. The data on the ATV, this is to be considered backup documentation, but anyway, it's a vehicle which is 19-ton vehicle that has a capability up to 7 ton of cargo. It is a first. It is a first for a number of performance. It is the first vehicle being completely automatic and doing the rendezvous and docking to the space station. It is the largest and most powerful vehicle going to the ISS, except the shuttle, obviously. It is the vehicle that has the largest refueling capability. It is the largest garbage can, if you want, because the station is consuming and generating a lot of garbage that needs to be disposed. The only download system is the shuttle and Soyuz, and that's by far not enough to get rid of whatever is generated above. So ATV is the largest eliminator of space waste, as we like to call it. And it is the only spacecraft that is powerful enough to make a delta V maneuver to deorbit the station. This was the beautiful launch that we had. Well, it was not so great weather, so we couldn't enjoy it too much, but the launch was flawless. It was a beautiful launch. You see, by yourself, it was extremely cloudy, so we lost the visual contact very soon. A few words about the mission scenario of the ATV. First part is achieved, launched and reaching orbit. The second is also achieved, is doing all the phasing and getting to the parking orbit that would allow then to enter the crucial part of the mission, which are Demo Day 1, this Saturday, Demo Day 2, 31st of March, and the docking on the 3rd of April. So what are we demonstrating in these days? This is a prototype. This is the first time this vehicle flies, and therefore it doesn't go straight to the station like Progress does. In Demo Day 1, we are approaching the station to a distance of 3.5 kilometers, and we are making all the necessary checkouts that are validating the functionality of all the subsystems that are required to get us there. So once we have done that and we have the full confidence to say, fine, I can go to 3.5 kilometers nominally without any anomalies, then of course I have the confidence to do one step further, to go at something like 12 meters. And this is all about Demo Day 2, where the ATV gets until there, then it checks other system, because obviously on Demo Day 1 is using GPS and differential GPS. In Demo Day 2 is doing visual, laser and other transducer, other sensors that are performing the rendezvous and docking. And once we have convinced ourselves that Demo Day 2 is a success, that all the equipment are working as they should, then we go to the docking on the 3rd of April. I am quite happy to report that we had a meeting yesterday with NASA, and where we gave the go-ahead with NASA and our Russian partner, I should say. So it was an ISS integrated meeting where we gave the go-ahead for the Demo Day 1 activity because the readiness is there. So at the moment we are crossing our finger. Saturday will be a very hot day for us because obviously it's a premiere, and we are extremely confident, but still we have to stay on our toes, and that's what we are expecting. This is a little drawing showing how we get to from the launch to the phasing to the parking orbit. This is the various points we are visiting for Demo Day 1, Demo Day 2, and the docking. And you can see the various dots are corresponding to different demo days. So again, 3.5 kilometers, as I said, for Demo Day 1, 12 meters for Demo Day 2, and 0 meter because it is docking for Demo Day 3, which is actual docking day. Before getting to the overall consideration, I would like to spend a few words on the status of the station, because I have dwelled quite a lot on the European element. But the ISS is a true cooperative program, and we are extremely happy to report that 2008 will be a great year where, well, first, the SPDM and the Kibo logistic module have been launched with the 1JA flight, which is returning this night at midnight, I guess, 7 o'clock Florida time. It has been a great mission, a great success. The Canadian Dexter arm is being installed and work being checked out and work properly, and together with the Japanese logistic module that is paving the way to the next flight that we are having, instead of space station obviously, that we are having on the 25th of May, where the core of the Japanese contribution will be on orbit. That's going to be a great day for the whole partnership and obviously for our Japanese colleagues. And we congratulate them in advance for this great success they're going to enjoy. After those launch, we are going to have two very important launch that are going to configure the station for the 2009. 2009 is the crew of 6 year, is when the station is going to achieve the capability of crew of 6. And in order to achieve that, you need the flight ULF2 in October that brings the life support for more crew member, and the flight of December, which is called 15A, that brings the last solar array. So the station will have now the shape that it has on all the artistic view, with the 4 solar array being deployed by the end of this year. So 2009 will be then the crew of 6 year, and this is obviously a great achievement which is ahead of us. Without a fantastic partnership, we would have never been able to achieve that. In particular, the work that NASA has performed since the shuttle returned to flight in July 2006 has been more than fantastic. The shuttle flight is flying with a frequency which is something like 5 flights a year, which is, even in the best years, was difficult to achieve. People were saying that after the Columbia we'll never be able to fly with this frequency. Now I think they are changing their mind, because the evidence is a bit different. We thank very much also for all the contribution that our Russian partner have providing the rescue vehicle, all the logistics, and solving so brilliantly the computer emergency that we had last summer, or let's say, last summer exactly. So now I think we are ready to have the overall final consideration and also the way forward in terms of agency, European Space Agency perspective. So with the ESA, the launch of Columbus, we have now a permanent outpost in space. This is just like having our real estate on orbit. In the past, we were guests. Now we own land. And that's mean a lot of difference for us. We are, of course, co-owner. We don't think that we own the space station. We know part of it, and we are quite happy with owning that part. What is ahead of us? Ahead of us, we have the successful docking of ATV in early April, as I have mentioned. We have the completion of the Columbus commissioning, and you have the completion of the ATV mission with the safe disposal in August. What have we demonstrated with this recent 3 launch? Well, we like to say that we are not successful because we are lucky. We are successful because we have primarily an industry which is competent and organized. This is all about success. If you are not competent and organized, then lucky is not good enough. You need some luck. We had it. We had also some rough day. But what we have achieved, most of all, is that we have qualified the capability of our industry to develop and operate complex and heavy manned space infrastructure, and we have qualified our industry by mastering the automatic rendezvous and docking technology. Those are the main objectives of our program. Now we have, of course, the objective of the exploitation. Now we have qualified our industry. Now we have qualified our capability. Now we have to be able to use it, to develop, enhance it. And that's what is ahead of us, an extremely exciting challenge. And we are looking forward to meet the demand of this challenge. Thank you very much for your attention.
Thank you very much, Bernardo.